Okay, good day to you, Ben, and welcome back again to your lesson in mathematics. And this time, probably this should be your last lesson in math in your grade level as being grade 6. Last meeting, in our previous lesson, we discussed about areas of a square, triangle, a rectangle, and a circle. Okay, and all of those areas have each formula to find the area. This time, we're gonna find the area of composite figures, or meaning figures that is composed of one or two polygons. Okay, so on the board here, we have here, for example, a composite figure, or if you can see on the board, it's the figure of a house. Okay, like a house. Okay, so it has a wall and roof. Okay, now, so there is this figure is composed of a square and a triangle. Okay, now we want to get the area of this composite figure that is composed of a square and a triangle. Now, to get the area of composite figures, all we need to do is just get the areas of the figures that we know already. Okay, on how to get those areas. Like, for example, all we need to do is just get the area of the triangle, get the area of the square. In that way, you can, by adding the two areas, you can get the area of this whole composite figures. Okay, so that's what we are going to do. So in our first example here, in our figure, we have here the height of the triangle, which is 6 centimeters, and the length of the side of the square is 7 centimeters. Okay, so supposing that or assuming that all of the angles here are right angles, or all of the angles here is a 90 degree angle. Okay, so that's in that way we can use the formula in getting the square. Okay, now the formula for now to get the area of this composite figure, all we need to do is just first we have to get the area of the triangle here, and we need to get the area of the square here, and all we need to do is just add the two areas. That way we can get all the area of this composite figures. Okay, so now we have here the formula in getting the triangle. The area of the triangle is 1/2 base times height. Now the area of the square is s times s, or side times side. Okay. So first, let's just get the area of the triangle here. If you're going to separate the triangle, we have here the figure, which is the height is 6 centimeter, and the base is 7 centimeter. So to get the area of the triangle, we need to use the formula, which is 1/2 base times the height. Then we substitute. Okay, so area of the triangle here is equals to 1/2, and that is our base is 7 centimeter, while our height, this one, is 6 centimeter. So in substituting, we have here area of the triangle is 1/2 times 7 centimeters, which is the base. Okay, here, and times 6 centimeters, which is our height. Okay, or the height of the triangle. Okay, so to further simplify this, 1/2 times, now 7 times 6, that's 42. Okay, centimeters times centimeters is centimeters square. Okay, so we have 1/2 times 42 centimeters squared into further simplify, meaning we have to divide 42 divided by 2. Okay, because 1/2 times 42 is same as 42 over 2. Okay, centimeters squared. Okay, now 42 divided by 2, that's 21. Okay, 21 centimeters squared. And that will be the area of our triangle here. Okay, so area of the triangle is equals to 21 centimeters squared. Okay, so that's for the triangle only. So next is we need to find the area of the square. Okay, so let's first write the illustration. And that is our square. The length of the side of the square is 7 centimeter. Meaning, if this side is 7 centimeter, because it is a square, all of the sides are also 7 centimeters. So all we need to do is the area of a square. Okay, area of a square is equals to S times S, side times side, and our side here is 7 centimeter times 7 centimeters. Okay, so to further simplify, 7 times 7, that's 49 centimeters times centimeters is centimeters square. Okay, so our area of our square here is equals to 49 centimeters square. Okay, so we have gotten the area of the triangle and the area of the square. All we need to do is just add the two areas. Okay, to get the area of the whole composite figure here on the board, so all we need to do is add the area of the triangle to the area of our square here. That will be our total area. Okay, so area of the triangle is 21 centimeters squared plus area of our square is 49. Okay, 49 centimeters squared. And let's add. So 1 plus 9, that's 10. Carry 1. 5 plus 2, that's 7. So 7 centimeters squared. Therefore, our answer here for the area of our composite figure here, which is composed of a triangle and a square, is 70 centimeters squared. Now, how did we get that? Is by getting the area of the figures that we know. Okay, like getting the area of the triangle and getting the area of the square, and adding the two, that will be our total area, which is 70 centimeters square. Okay, so let's have some more example. Okay, for our next example here, then on the board, we have here a rectangle. Okay, as you can see on the figure, we have here a large rectangle, and we have here a small rectangle that overlaps the large rectangle. Okay, so what we want is we want to get the area of this figure. So how do we do that? Simply by just getting the whole area of this rectangle and subtracting that to this area of this rectangle that overlaps the large rectangle, because this one is hollow, but as you can see, it's like it forms a rectangle too. Okay, so all we need to do is just get the area of this the whole rectangle, subtract that to the area of this smaller rectangle. Okay, so first let's get first the area of the large triangle. other large rectangle, which is area of rectangle is length times the width. Now our length here is 10 feet. Okay, times our width here is 6 feet. Okay, the width of our rectangle. And to further simplify, 10 feet times 6 feet is 60 feet squared. Okay, and 60 here is the area of the large rectangle. Okay, that is 60 feet squared. Next, we want to get the area of the smaller rectangle here that overlaps the bigger rectangle. Okay, so we have here its length, which is 4 feet. Okay, the area of the smaller rectangle is equals to, S here is small, length times the width. The length of our smaller rectangle here, the length is 4 feet, times, now the height here is 3 feet, which is already given. So, or the width, I mean, the width is 3 feet. So to multiply that, 4 feet times 3 feet is 12 feet squared. So this is the area of our smaller rectangle, and that is 12 feet squared. Okay, so all we need to do is, if you want to get the total area here, is subtract, okay, from the area of our large rectangle minus the area of our small rectangle. Okay, and that will be the area of our composite figure. Okay, so the area of our large rectangle minus the area of this small rectangle, and what's left is the area of our composite figure. Okay, so let's do that. Now, what's the area of our large rectangle? That is 60 feet squared. Okay, 60 feet squared minus, okay, the area of our small rectangle, which is 12 feet. Okay, 12 feet squared. We're going to subtract that. If you can see it, let's put it in here. Okay, now 60 minus 12. Now 0 minus 2 cannot be, so 0 must power 1 from 6. So 6 will become 5, 0 will become 10. So we can subtract now. 10 minus 2, that's 8. And 5 minus 1, that's 4. So we have 48 square feet. Okay. So for our area here of the total area, that's 48 square foot. Okay, or 48 feet square. So that's how we get the area of composite figures. Ben. So all we need to do is just get the areas of the figures that we know how. Okay, and that's how we get the areas of composite figures. So thank you for your time, Ben, and enjoy your summer.